Welcome to Chapter 3, Video 6 in the GCSE Physics series from Physics De-Mystified. This time, transformers and motors. So firstly, transformers. Now, transformers change the voltage of an alternating electricity supply. And remember, they only transform AC current, not DC, not direct current. So how do they do this amazing thing, changing a voltage? Well, it all involves coils of wire, an iron core, and the fact that electricity and magnetism are inextricably linked. Now here's a simple representation of the construction of a transformer. A primary coil is an electric cable wrapped around a soft iron core. It's connected to an input power supply providing alternating current. The alternating current creates a changing magnetic field in the soft iron. The changing magnetic field in the soft iron core causes a voltage to be induced in the secondary or output core. That's the only connection between those circuits. Through the magnetic field, there's no electrical connection. So the number of turns in the primary and the secondary coil determine the change in voltage according to this equation. The primary or input voltage divided by the secondary or output voltage is equal to the number of turns on the primary coil divided by the number of turns on the secondary coil. It's a simple ratio of coils to coils reflected in the ratio of voltage to voltage. And it works both ways, which enables you to change the voltage by increasing or decreasing it, depending on which coil has the greatest number of turns. So for example, this transformer has 6 turns on the primary coil and 3 turns on the secondary coil. The input voltage of the primary coil is 100 volts. The question is, what is the output voltage? Well, using the formula we've just looked at, we can divide the number of turns on the primary coil by the number of turns on the secondary coil. In this case, we get 6 divided by 3, which of course equals 2. To calculate the output voltage, therefore, we can state that the voltage ratios must also equal 2. Thus, this ratio, 2, therefore equals 100 volts divided by the output voltage. Rearranging this formula to make the subject the output voltage, we can see that the output voltage is 100 volts divided by 2, which gives an output voltage of 50 volts. And remember, a step-up transformer increases the voltage. It has more turns on the secondary coil than the primary. And a step-down transformer decreases the voltage. It has more turns on the primary coil than the secondary coil. Okay, so motors. Now, an important part of electricity that you need to know is how motors work. A current-carrying wire has a circular magnetic field around it. The field is made up of concentric circles. And when a current-carrying straight wire is placed in a magnetic field, it experiences a force, and this force can make the wire move. Now, the direction of this force can be found using Fleming's left-hand rule. A hand is held out, a left hand, with 2 fingers and the thumb perpendicular. Thus, the first finger is pointed in the direction of the field, from north to south of the magnetic field. The second finger indicates the direction of the current. Finally, the thumb then shows the direction of the force, which direction the wire will want to move in. Now, motors take electrical energy and transform it into kinetic movement, kinetic energy. This simple motor runs on a DC, a direct current from a battery. Now the current flows in the coil, which experiences a turning effect caused by the magnetic field. Now the forces on the coil can only pull the coil half a turn, because the forces will then be pulling it the wrong way, it'll stall. So a motor allows the coil to continue to turn by changing the direction of the forces, and it does this by changing the direction of the current in the coil. As the coil spins, the commutator spins, but the brushes remain in the same place, changing the direction of the current every half turn. A stronger turning effect is produced by increasing the number of turns on the coil, increasing the current, and using a stronger magnet. Now, motors are found in, well, a variety of everyday applications, such as washing machines, tumble dryers, media players, computer hard drives, and electric drills. Electric motors, also very large ones of course, also power some ships and railway engines. Just before we go, a little reminder of what you need to remember. So in summary then, a transformer changes the voltage of an alternating current. The effect depends on the number of turns on the primary coil and the secondary coil. Fleming's left-hand rule can be used to find the direction of a force felt by a current-carrying wire in a magnetic field. A DC current in a coil placed in a magnetic field can be used to make a motor. So now we know how electricity is produced and distributed, we can next time turn our attention to electricity in the world. Meanwhile, if you haven't already done so, make sure you never miss an episode by subscribing to our channel, and also click the bell to receive updates when new content is uploaded. Until then, thank you for watching, and remember, keep wondering about the universe.